This is part 1 of section 13.1 on probability. I'm going through the in-class notes so that you can follow along. The notes themselves are in Moodle. So some definitions we need to be familiar with. An experiment is any observation of a random phenomenon like flipping a coin or drawing a card. Different results of that experiment are called outcomes. The set of all possible outcomes for an experiment is called a sample space. And an event is any subset of that sample space. So let's look at example 1. We observe the random phenomenon results of flipping two different coins simultaneously. So that is our experiment. So what are the possible outcomes on each coin? Well, they can either be a head or a tail. Now the sample space is all possible outcomes. So that means when we flip our coin, coin 1 could be a head or a tail, and then coin 2 could be a head or a tail. Coin 1 could have been a tail, and then the second one a head or a tail. So our sample space are all of these possible outcomes. So that would be head, 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 tail, tail, head, and finally tail, tail. So that is our sample space. There's a total of 4 possible outcomes in our sample space. Now the event, the subset of the sample space that we're interested in considering, is when the two coins land with the same side up on both of them. So a success for our sample space would be they're both heads, or they're both tails. Now we're going to use what we're finding here to calculate probabilities. And an intuitive look at, a visual look at probability is this continuum that goes from a probability of 0. This is 0. So that's not going to happen. If the probability is 0, not going to happen. But if it is 1, this is a probability of 1, probability of 0. If it's a probability of 1, then it is certain. It's absolutely going to happen. Now, in that continuum is anywhere between 0 and 1. If it's in the middle, you've got a 50-50 chance. If it's between the middle and the 1, then it's likely to occur. But if it's below, so if we have less than a 0.5 probability, it's not likely to occur. Mathematically, the probability of an event is calculated using the ratio. Here's our notation. This is the probability of E represents the defined event. And that comes from the ratio of the number of times the event occurs divided by the number of times the experiment is performed. Another way to think about it, the probability of a particular event is the ratio of the number of wanted outcomes, or you will hear me say the number of successes, the things that we're looking for. And again, it's divided by the number of all outcomes, which is represented by our sample space. So now that we've gone through the basics, let's look at some examples. 4 cards with pictures are used in testing ESP. There's a circle, star, wiggly line, a dollar sign. Outcomes in the sample space are represented by pairs of letters such as WS, representing wiggly lines and star, and SC, which would be star and circle. Now, since I'm recording this from the PowerPoint, it is cutting off some of the edges of your question, but this question in its entirety is in your in-class notes, which is also in Moodle. So the first thing we need to know is how many elements are there in our sample space. And let's see, I'm going to list those. Well, first let's count them. There are 4. So our sample space we will have a star, circle, star, wiggly line, star, dollar sign, and then we'll have a circle, star, circle, wiggly line, circle, dollar sign, and a wiggly line, star, wiggly line, circle, wiggly line, dollar sign, and finally dollar sign, star, dollar sign, circle, dollar sign, wiggly line. So I've listed all the possible outcomes, and there are 12 of those. We could also have thought about counting them using our counting principles. We're going to choose 2 cards. There's my first card, and there is my second card. There's 4 possibilities to choose the first one, but once I've chosen that one, there are only 3 possibilities left to choose the second one. That makes a total of 12 both ways. In something like this, listing the sample space will also help us answer probability questions. So our sample space, the total number of outcomes is 12, and we want to describe the event wiggly lines appear on one of the cards. So we'll go through our sample space, and that will be, so we're going to have a W on a card. Well, that will be an SW, a CW, I'm leaving the commas out here, a WS, a WC, a WD, and a DW. So there are six ways where we can pull out 2 cards, and one of them is a wiggly line. So now we want to calculate the probability that the wiggly line appears on one of the cards. So remember, we're looking for the number of successes over the total number. So we're going to do the probability. It's a card with a W. And that's going to be how many ways do we have a card with a W? Well, that's the probability of our event. And that will be 6 divided by the elements in the sample space, the total number of ways we can pull 2 cards, and that is 12. And when we calculate that, we get 0.5 as our probability. So this is one of those where it is a 50-50 chance. Now, what about the probability that a star does not appear? So now we've got the probability no star. So we know that we're dividing by 12. How many cards are there that do not have a star? Well, there's 1, 2, 3, 4, 5, 6 ways to draw 2 cards, and a star is not one of them. So again, we have 6 out of 12. That makes our probability again 0.5. In our next example, we're going to use some different counting principles, and I'm going to stop this video here and start a new video since my recordings need to be under 15 minutes. So this will be part 1, and we'll pick up with example 3 in part 2.